So today we're continuing on what we did Friday with this here simplifying. We're going to look at one of these here in a different type, which really isn't different once we see the main key concept to it. Now this one here, we're going to have two fractions. Now we can start with the top left, our c cubed plus 8. Well, c cubed plus 8, c is a perfect cube. 8 is a perfect cube because we can multiply something by itself 3 times to get c to the third and 8. For c to the third, it's going to be c. What times itself 3 times is 8. 2. So this would be our sum of perfect cubes. Sum of perfect cubes. Now the signs of this would be what? Well, the same, opposite, always end on a positive note. And I need one more space there. 1, 2, 3, 4, 5. Opposite, positive. Now our first term, what we'd call A normally when we went over this, would be our C. So this would be C. Here we're going to have C squared, and then we'll have C to the first and then C to the 0. Questions on this here so far? Some of this coming back from last chapter, or the last section we covered. Now what goes in the other spot would be 2. So here we would have 2. We wouldn't put anything with the C squared. In the middle we would have 2. And the last one we would have 2 squared. And this is kind of following that sum of perfect cubes, sum indifferent of perfect cubes pattern. Now there is some stuff we can simplify. The 2c is, we can rewrite it, I have already written it, but the only other thing we really need to simplify is 2 squared. Yes? Because that's the only other thing we can simplify. We can simplify it here in a minute. Now, if we look at the denominator of the first fraction, we have c to the 5th minus 4c cubed. What can we do to simplify this, to factor it? Yes, and that's where I would start. I would start out by factoring c cubed because there is a greatest common factor of c to the third, so we can factor it out. Now, if I factor c to the third out of c to the 5th, I take 3 away from c to the 5th. I'm left with c squared. Minus, well, we didn't do anything to the 4, so it stays. And if I factor c to the third out of c to the third, well, they simplify out completely, which leaves me with c squared minus 4. Well, will c squared minus 4 factor? What's the difference of perfect squares? Well, we already have to do some simplification already. We'll factor that in a minute. Because I don't want to factor it again because then we're going to get ahead of ourselves, yes? Because there's going to be more writing, more scribbling. Okay, let's look at the top here. C to the 6th minus 4c to the 5th plus 4c to the 4th. What can we do? There's a greatest common factor of what? C to the 4th. Which will leave us with c squared minus, well, we didn't do anything to the 4th. C to the 5th, if I factor out c to the 4th, we're left with c plus, well, 4. Any questions on this here so far? Okay, so that leaves us with the last one here. Now, yes, we can factor c squared minus 4c plus 4. That is factorable. We'll factor it here in a minute. Now, the only thing we have left is c squared minus 2c plus 4. All right. Since the 4 is positive, the signs are the what? The same, and they match the sign of the middle term, which would be negative and negative. The factors of c squared are c and c. Now the factors of 4 are 1 and 4 and 2 and 2. They're going to have 1 and 4 or 2 and 2. Now which one do we want to try first? So if we check it, negative 2 times c is going to be negative 2c. Negative 2 times c is going to be minus 2c, which will give us negative 4c. Is that what we wanted? Well, no, we wanted minus 2c, correct? Okay. So we'll switch it out with 1 and 4. c times negative 4 would be negative 4c. Negative 1 times c would be negative c, which gives us negative 5c. Is that what we wanted? No. Do we have any other ways we can set this up? Well, no, right? So the c squared minus 2c plus 4. Wait a minute. This here is really a 4, isn't it? So what do we have here? C squared minus 2c plus 4, yes? Now, the quadratic that comes out of a sum or difference of perfect squares, is it ever factorable? Well, no. It works out that the sum, this quadratic that comes out of the sum or difference of perfect squares will never be factorable. And it works out that this c, or c squared minus 2c plus 4 isn't factorable. There's nothing we can do with it. That is as simplified as it gets. Now, I will say this, even if it is factorable, if we notice that c squared minus 2c plus 4, I have it right here, yes? And I have it right here. Is there any real reason to simplify? I mean, if they're going to be the same already, won't they already cancel out? Yeah. The only reason we would really need to factor it is to figure out what values of x is going to make the thing equal 0 for our restrictions. That's going to be the only real difference. Well, all right. So we can multiply this together, yes? Well, if I do that, they're going to be, well, wait. We still have some simplifying to do first. The c plus 2 doesn't simplify. But our quadratic, the c squared minus 2c plus 4, because we'll need to simplify 2 squared. On the bottom, we have c cubed. Well, the c squared minus 4 does factor. And what would it be? C squared minus 4, how would that factor? Because that is a difference of perfect squares. So the signs would be opposite. We have c plus 2 and c minus 2. Now on the bottom here, c squared minus 2c plus 4, that's as simplified as it gets. Now the only thing we have left to factor is c squared minus 4c plus 4. Since the 4 is positive, the signs are the what? They're going to be the same. And they're both going to be negative, because they match the sign of the middle term. Now the factors of c squared would be c and c. Now what would be our factors of 4? 2 and 2. And this here works. And we kind of already saw a minute ago when we tried doing the factors of c squared minus 2c plus 4 that c minus 2 times c minus 2 would give us negative 4c for the middle term. So we get this here. Now, are there any questions on anything we've done so far to get here? Okay, well now we multiply them together, yes? Well, I feel like being lazy. All right, we did it. I mean, they're all going to be on 1, so might as well. I mean, it's easier to draw a line. I don't know about y'all. I don't want to write all that again, do you? No? Okay, let's see what's in common in both of these here. So what do we know for sure is in common in both the top and bottom, numerator and denominator? So we have a few things. Those would simplify out. They'd become 1. What else? C plus 2 and C plus 2 would simplify. C minus 2 and C minus 2. One of the C minus 2s on top and one of the C minus 2 on bottom. Anything else? Yes. And that would leave me with how many on top? 1, because 4 minus 3 is 1, and it's biggest on top. Because really, we're saying all 3 of these are multiplied together, yes? So C times all this. We have it on top and bottom. Now, another way we could have looked at it, if we rewrote it, if I rewrote it, it would have come out here as C to the 4th. C to the 4th over C cubed would become this. So what do we have left on top? Well, we have C. What else do we have? What do we have? Do we have anything left on bottom? No. After we simplify it, we're left with C times C minus 2. Now we still need to find our restrictions. So the things that simplified out on bottom were C cubed, C minus 2, C plus 2, and C squared minus 2C plus 4. We have these 4 things. They were all in the denominator, and they all simplified out, yes? Now, what did we say about C squared minus 2C plus 4? Why didn't we factor it or do anything with it? It's already simplified. We don't have any factors, or let's actually be more mathematically correct. We don't have any real factors. It is factorable, but we get imaginary factors. We have I. So since we don't have any real factors, does that mean, is there any values of C that I can make this thing become 0? Well, no, because there are imaginary solutions. There are no real solutions for this here. So if there's no real solutions, will C squared minus 2C plus 4 ever be 0? Well, no, because if it has solutions, that's the values of the variable that will make it equal 0. So if it doesn't have solutions, there's no way for this to actually equal 0. So that just leaves us with the other 3. And we need to see what values of x are going to make these 0. So we need to see what value of C is going to make C cubed equals 0. Well, that would be what? Because we could solve it by taking the cubed root of both sides, and if we take the cubed root of both sides, well, we would just get C equals 0. How about for our next one? What's going to make C minus 2 equal 0? 2. Because 2 minus 2 is 0. And last but not least, C plus 2. What's going to make C plus 2 equal 0? And that's it here. That is all we have here. Any questions on any of this here? All right. We're going to skip over that one, and we're going to look at example 4. Find the product of these two here. This is the last one we'll be doing today, the last one we'll cover. And this one here isn't really any different than what we just did previously. So we have two things being multiplied together. Find the product of these two. Well, x plus 2 doesn't simplify, or we can't factor it, because that is as simplified as it gets. X plus 2, that's it. That's all we have. Now, the denominator is x cubed minus 27. That is the sum. Actually, that's the difference of perfect cubes. 27 is a perfect cube. X to the third is a perfect cube. So we do have the difference of perfect cubes. Okay, then we've got, wait a minute. The other one's not a fraction, is it? X squared plus 3x plus 9. Do we have anything in the denominator of that? It does have a denominator. It's just 1. We do have a denominator there. We do have a denominator there. So we can write that in. You don't have to, but it's probably a good thing to do just because when we start multiplying, to make sure we don't multiply the top and bottom by this here. It's only the top. Okay. Now, before we do anything with the x squared plus 3x plus 9, let's factor x cubed minus 27. Now, the cubed root of x cubed is going to be x. And I kind of list it out so I know what's my first term and what's my second term, or the other term. Now, the cubed root of 27 is 3. So that kind of lets me know I can take the cube, or factor this as a difference of perfect cubes. Okay, let's look at the signs. So the signs are going to be the same. So minus. Opposite would be plus. Always end on a positive note. So we have minus, plus, plus. Now we'll plug in the x terms. So the first spot we'll have x, nothing. Then we'll have x squared, x in the middle. Any questions on this here? Now we can plug in the other term, so 3. Nothing the first, we'll have 3 in the middle, and then we'll have 3 squared. Any questions on this here? Wait a minute, does that quadratic look a little similar? This one here does, doesn't it? X squared plus 3x plus, well, 3 squared is. You know what we have up here already? So for starters, we're not even going to try to factor it, because since x squared plus 3x plus 9 was the quadratic part of the difference of perfect cubes, it means already that this will not factor. It just won't. So we're not even going to try to factor it. Well, the last thing we need to do is, well, I'm going to multiply them together. X plus 2 times x squared plus 3x plus 9 is going to be over. Well, we have x minus 3. Here we'll have x squared plus 3x, and 9 squared gives us, or 3 squared gives us 9. Any questions on this here? So what's in common on top and bottom? X squared plus 3x plus 9, yes? And what does that leave us with? X plus 2 over x minus 3. So that's the only thing left in common. Now, me and the textbook disagree over this. Mainly, it's just semantics. There's not a real big disagreement with this here. I think we should list every restriction. The book is just going to have you list the ones that were eliminated or simplified out. Well, what was the only thing that was simplified out? Well, the x squared plus 3x plus 9. Well, it's the quadratic of a sum or difference of perfect cubes, yes? So will it factor? So will it have solutions? So do we have any restrictions for this quadratic? No. Well, the only other restriction is our x minus 3, yes? So according to the textbook, well, it's already there, isn't it? So we don't need to list it. But if we did, what would it be? Well, it would make x minus 3 equal 0. And that's it. That is it. Any questions on any of this here? Okay.